Okay, today we're going to talk about the difference between two things in mathematics, two types of functions. And then we're going to solve a problem that requires this knowledge. So the first word that we're going to talk about is called a linear function. Okay, and then we're going to compare it over here on this side to the other kind of function, and that would be an exponential function. So these are the two that we'll talk about today. And first of all, I want you to be able to tell the difference between these two by looking at a graph. So if we have a graph of a linear function, that means that our graph is going to look like, what do you think? What word do you see in linear? You see this? Whoops, I need to draw that line again. Excuse me. Okay, now we have our graph set up. But do you see this word here? The word line in linear function. And that means that the picture is always going to be a line. It might be straight up and down, it might be sideways, it might be on an angle. But so points for a linear function will always be in a line. Okay? Now let's come over here and get a graph for an exponential function. And we're going to get something different with an exponential function. It's going to look kind of like a Nike swoosh. It'll be a curve where things start to increase at a fairly slow rate, but then as time moves on, or as you move further down the x-axis, the y value will increase really fast and become steep, quicker and quicker. It's called exponential growth. You've probably heard people say that phrase. It grew exponentially, even if it wasn't in a math setting. That means that it grows more and more with time. Okay, so let's go ahead and draw what that would look like. So you can see the growth starts out kind of small, but then it picks up and picks up and picks up, and you get something like this. Now, these are both growth functions, where they're increasing. We could also have a decreasing function, and let's do those in red. So a linear function that decreases just means maybe you have something here. You have points that form a line that go down, so they have a negative slope. And an exponential function that is decreasing is just going to be one like this, that starts out steep, but then decreases slowly with time. So that would be, it's getting smaller and smaller, right? Okay, so this is the difference of the pictures. You can see that an exponential function is never going to give you a straight line. It will always have a curve. And linear functions are always straight. So that's that. Pretty simple. But we also want to be able to know what the differences between the functions looks like when you're just given the points, the coordinate points, or a table with the values. So let's just say that I have, we're going to choose a different color here. Let's just say that I have an x and y table for linear function. Okay? Now, we're going to get something like this. We'll say if x is 0, 1, 2, and 3, we'll just do a few. Maybe y starts out at 5, and then goes up to 9, then 13, and then 17. You can see here that there's a pattern for all of the y values. As we go up one value in the x direction, so when we go up 1, how many do we go up in the y? We're adding 4. And you can see that that pattern continues. So if I add 1 in the x direction, then I add 4 to get to the next value, and so on and so forth. So you're adding or subtracting. If it's decreasing, then you'd be subtracting, but the same amount every time. Okay, now we're going to contrast that with an exponential function. So here, let's do a nice little x and y chart. And we're going to get something that looks a little bit different, as you may expect. Okay, we'll start out the same here when x is 0, 1, 2, 3. Now when x is 0, we're going to say that y is 32. Oops, I'm sorry. No, that works just fine. And we're going to say when x is 1, that y is 64. When x is 2, y will be 128. When x is 3, y is going to be 256. So, okay, let's do the same thing we did last time. We notice when we go from 0 to 1, we're adding 1 here. How much do we add? From 32 to 32 to get to 64, we had to add 32. But you'll notice to get from 64 to 128, we have to add a lot more than 32. So instead of adding the same amount every time, you'll notice that we'll be multiplying by a number over and over. That number is called the common ratio. So what number do we have to multiply 32 by, to get 64? Well, here we just, to get from here to here, we multiply by 2. So every time I add 1 in the x direction, I'm multiplying the y value by 2. You can see that? I add 1 here, and I multiply by 2 to get to the next value. 32 times 2 is 64. 64 times 2 is 128. 128 times 2 is 256. So the difference when you look at a chart is you're looking for a pattern of either multiplication or addition. If we're multiplying, then we know we've got an exponential function. If we're adding or subtracting, we've got a linear function. Okay? That's good for now. These numbers up here, I'm going to solve in a video that's separate from this one, because this one's getting a little long. So I'll let you take a break. If you want to see me look at some data and determine if it's linear or exponential, go ahead and watch the next video. Thanks for watching.